Far below the ocean's surface exists a hidden realm humanity was never meant to witness. A place where sunlight fades away and life evolves into shapes that feel almost unreal. As we move downward through the layers of the sea, passing the sunlit waters, slipping into the dim twilight, and finally approaching total darkness, the organisms we encounter grow increasingly strange. We've explored Mars with robotic explorers. We've charted galaxies billions of light years away. Yet the deep ocean remains largely unknown. Less than 5% of it has been studied. In fact, we understand the surface of the moon better than what lies nearly 6,000 feet beneath our own seas. At the ocean's surface, life thrives in abundance. Sunlight drives massive blooms of plankton, forming the foundation of food chains that support everything from small fish to giant whales. Coral reefs flourish, ecosystems buzz with movement, and energy flows freely. But descend beyond 200 meters, and light begins to disappear. This marks the entrance to the twilight zone, a massive layer of ocean extending down to about 1 kilometer deep. Here, sunlight is too weak to power photosynthesis. Plant life vanishes. No algae, no plankton forests, no green energy. Instead, survival depends on a slow, steady rain of organic debris drifting down from above. Scientists call this falling material marine snow, tiny particles of waste, dead organisms, and decaying matter. To us, it seems insignificant. To the creatures here, it is everything. Where food exists, life follows, but not in familiar forms. The animals of the Twilight Zone have evolved into some of the most unusual beings on Earth. Many are nearly transparent, their bodies resembling fragile glass. The glass squid floats with organs barely visible, like a drifting phantom. The glass octopus is almost impossible to see, its eyes standing out as the only solid feature. Why transparency is so common remains unclear. It may help animals blend into the faint light that filters down. Or it could be an energy-saving strategy. Pigments require resources, and in this environment, every advantage matters. Others adopt a completely different tactic. They produce their own light. Through a chemical process called bioluminescence, countless creatures glow in the darkness. To humanize, it's mesmerizing. Flashes, pulses, glowing outlines, bodies shimmering like living lanterns. But here, light is not decoration. It is a tool for survival. Some species use light to attract prey. Others signal potential mates. Some even use it to vanish. This technique, known as counter-illumination, allows animals to erase their silhouettes. Predators hunting from below look for dark shapes against the faint glow above. To counter this, creatures like the firefly squid emit light from their undersides, matching the brightness of the surface glow and blending perfectly into the background. A light is used to hide within light itself. Other adaptations are even stranger. The bloody belly comb jelly glows a deep red. Since red light cannot travel far in deep water, this makes the animal appear pitch black. Any bioluminescent prey inside its stomach remains hidden, invisible to predators that might otherwise notice the glow. In a world ruled by darkness, survival depends entirely on who can be seen and who cannot. Yet the Twilight Zone is more than a theater of visual deception. It is also home to one of the greatest natural events on the planet. Every night, as darkness falls above, billions of creatures rise toward the surface. Lanternfish, squid, jellyfish, and countless others ascend together to feed on plankton under the cover of night. By morning, they retreat back into the depths. This phenomenon, known as diel vertical migration, is the largest synchronized movement of life on Earth, greater than all herds, flocks, and swarms combined. Remarkably, it went unnoticed until World War II, when sonar operators detected what appeared to be a mysterious moving seabed. The ocean floor wasn't shifting. Life was. An entire hidden world rising and falling as one. The Twilight Zone is where the rules of biology begin to bend. Transparency becomes protection. Light becomes camouflage. Billions of animals move in rhythms older than civilization itself. This is the gateway to the deep, a boundary beyond which mysteries multiply. Below 1 kilometer, sunlight disappears entirely. We enter the midnight zone, extending down to 4,000 meters. There is no dawn or dusk here, only perpetual night. Temperatures hover near freezing, and pressure reaches hundreds of times that at the surface. To humans, it feels utterly uninhabitable. Yet evolution thrives here in astonishing ways. Consider the dragonfish. Unlike most deep-sea animals, it produces red bioluminescence. Since red light is invisible to nearly all other creatures at these depths, the dragonfish wields a private flashlight, illuminating prey without revealing itself. Even more extraordinary, its eyes are adapted to see this hidden color. It has access to a secret visual channel no one else can perceive. Other predators rely on disappearance rather than illumination. Some fish are coated in ultra-black skin that absorbs nearly all incoming light. Even when illuminated by submarine spotlights, they barely reflect anything, dissolving into darkness. Then there are the anglerfish, perhaps the most iconic hunters of the deep. Females dangle glowing lures to draw prey close, but their reproduction is even stranger. Males are born tiny and fragile, their sole purpose to locate a female in the vast darkness. When one succeeds, he bites onto her body and fuses permanently. Over time, his organs deteriorate until only reproductive tissue remains, sustained entirely by her bloodstream. It is one of the most extreme reproductive strategies known to science. Not all deep-sea life hunts. Many species are scavengers, waiting patiently for food to fall from above. When a whale carcass sinks into the depths, it becomes a lifeline, supporting entire ecosystems for decades. Despite advanced submersibles, our understanding of the midnight zone remains incomplete. For every species identified, scientists believe many more remain undiscovered. Each expedition reveals creatures with glowing eyes, needle-like teeth, or bodies so delicate they collapse when brought to the surface. Descending further, at around 4,000 meters, we reach the abyssal plain. This vast region covers more than half of Earth's surface, yet remains one of its least explored habitats. The landscape is flat and barren, endless mud stretching in all directions. Temperatures rarely exceed 4 degrees Celsius. Food is scarce, and survival requires extraordinary adaptations. One such adaptation is size. Many abyssal creatures are giants compared to their shallow water relatives. Giant isopods grow as large as small dogs. Amphipods can reach the length of a human hand. Even the colossal squid is believed to roam these depths. This phenomenon, known as deep-sea gigantism, remains poorly understood. It may conserve energy or deter predators, but no single explanation fits all cases. When massive animals from above fall into the abyss, life responds rapidly. A whale fall becomes a biological jackpot. Scavengers arrive within hours, followed by specialized species like bone-eating worms that extract nutrients from skeletons. Entire communities flourish until nothing remains. Some creatures survive on far less. The vampire squid, despite its name, is not a predator. It feeds on drifting marine snow, using long filaments to collect particles. Even in oxygen-poor waters, it survives using an exceptionally efficient blood pigment. Life in the abyss moves slowly. Growth is gradual. Reproduction is rare. Some animals live for centuries. The Greenland shark, which can inhabit these depths, may live over 400 years, the longest lifespan of any known vertebrate. Here, time itself feels stretched. Beyond the abyss lie the ocean trenches, the deepest places on Earth. These scars form where tectonic plates collide and the seafloor plunges downward. This is the Hadal Zone, named after the underworld. It begins around 6,000 meters and descends to nearly 11,000 meters. If Mount Everest were dropped into the Mariana Trench, its summit would still be submerged. The conditions here are extreme beyond imagination. Near freezing temperatures, crushing pressures more than 1,000 times those at the surface. And yet, life persists. Snailfish with soft, gelatinous bodies thrive here, becoming the deepest living vertebrates ever recorded. Their flexible skeletons and specialized molecules allow their cells to function under immense pressure. Smaller creatures abound as well. Amphipods swarm the trench floors in vast numbers. Alarmingly, plastic fibers have been found inside their bodies, evidence that even the deepest ecosystems are touched by human pollution. At hydrothermal vents, life takes an entirely different path. Here, Microbes feed on chemicals like hydrogen sulfide and methane instead of sunlight. Entire ecosystems form around these vents, proving that life can exist without photosynthesis, an insight that reshapes our understanding of biology itself. These discoveries raise profound questions. If life can thrive in such extreme conditions on Earth, could it also exist in alien oceans, beneath the icy crusts of moons like Europa or Enceladus? Studying Earth's deepest waters may help us understand life beyond our planet.